Hello everyone and welcome to Quality Simplified. Friends, we are discussing basic tools of quality and we have discussed so far in part 1 of this video session check sheet, process flow chart and Pareto analysis. In this part 2, we will discuss cause and effect diagram, widely known as Ishikawa diagram or fishbone diagram, and graphs and histogram. So let's proceed with part 2. Welcome again to part 2 of basic tools of quality. Let's start second part with cause and effect diagram, also called as Ishikawa diagram or fishbone diagram, which is used to find root cause to any issue. You may see some versions of this diagram based on number of elements, that is man, machine, material, method, environment, etc. used for and their names. Some versions consider measurement method also as one more element. These elements are very easy to apply for manufacturing, engineering business as they have a natural fit with these businesses. But if I consider other business, then the clarity about general understanding of these elements, terms, becomes very important for its usage. This itself could be a reason why cause and effect diagram is used more in engineering manufacturing businesses than other businesses. So let's have examples specifically from other business or situation to make this point as well as final aspect of cause and effect diagram very clear. First example is from a car leasing company and the problem considered is low fuel efficiency of a car given on lease which affects the business adversely. Let's see how elements mentioned above can be applied in this case. Man, the person that is driver who is responsible for running of a process that is driving, his or her driving habits, how closely they comply with recommended way of driving, for example, avoiding sudden braking, acceleration, using right speeds when gears are changed, etc. Also, how the general maintenance and checks are handled by this driver would influence fuel efficiency. Machine. The car itself is a machine here. The specified designed fuel efficiency of a car model or actual fuel efficiency of a specific product being used will impact outcome here. Material. The consumable material here would be fuel, engine oil, tires, etc. Quality of these consumables can affect fuel efficiency. For example, use of adulterated fuel or non-standard tires will lower the fuel efficiency. Method. How adequate, comprehensive, practical is the recommendation of driving usage maintenance tips given by manufacturers would make a difference here. For example, ease of following gear changing speeds, maintaining tire pressure, feasibility of maintenance schedule, etc. will decide the fuel efficiency of a car. In case of commercial vehicles, overloading also could be one critical factor. Environment could mean road conditions or even climatic conditions which can severely affect fuel efficiency. For example, poor roads with potholes would mean driving in first or second gear for most of the time at low speeds will reduce fuel efficiency. Colder climatic conditions could mean engine is likely to run at a lower ideal working temperature. Hot climatic conditions may need excessive use of air conditioning and cooling of engine would mean lower fuel efficiency. Management, which could mean upkeep of car through proper maintenance, use of fuel from reliable sources, planning of routes, driving time, the management of all these factors would influence fuel efficiency. Hope this clarifies how the terms which are manufacturing friendly apply in different situations and also they are used in cause and effect diagram. Let's take one more example from non-manufacturing non-engineering area to have a better understanding. Suppose one person misses a step while climbing up the staircase and escapes a serious fall. Let's try to know the likely root cause using this tool in this diagram. Man, the person who is executing the process, that is climbing the steps, may not be attentive while climbing steps, or may be weak or old, that is lacks strength to comply with ideal safe way of climbing steps. Machine, here we can take staircase itself as a machine and its condition like slippery surface, broken steps, lack of holding, rail, etc. could be a reason of likely fall. Material, there may not be anything which can be called as material as nothing gets consumed here in this process very obviously. Method, process definition, adequacy of recommendation for safe climbing, etc. That is safety precaution, instructions for low light, etc. would influence the outcome here. Environment, poor lighting, wet surface, worn out steps would mean more likelihood of fall. Management, it could be a maintenance management of staircase, that is upkeep of steps, lighting to avoid undesired outcome, etc. Friends, these examples were chosen deliberately to clarify not only the finer aspects of cause and effect diagram, but how the elements can be interpreted and used, especially in non-engineering, non-manufacturing businesses. This underlines the fact that cause and effect diagram can be used in any situation, in any industry for finding a root cause. We use graphs, which is one more basic tool of quality, frequently, especially in professional life. Graphs helps us to understand behavior, relationship of a parameter over a period or with respect to other parameter at a glance, than spending time and energy in trying to read and interpret from lengthy data sheets. If the data sheet is too large and complicated, it becomes practically impossible to interpret the trained behavior from check sheet. The finer aspect which I am talking about here is not graph, but the type of graph used for understanding the trend, variation, relative behavior, etc. Let's have a deeper look at this aspect, how choice of right type of graph helps us in correct interpretation. The first example shows failures of cars manufactured in various months as of date. The trend here is meaningless as car from later batches like April, May 24 will always have lesser failures as it would have run use much less compared to earlier production batches like June, July 23. So declaring that latest batches have less complaint is incorrect going by this trend. To avoid this bias, we can use another type of graph which shows failures of various production batches over certain kilometers range like 5, 10, 15,000 kilometers. This data is used and it is certainly comparable to draw inferences. In this example, the inference could be U23 batch shows considerably higher failures than any type other batch and needs attention. It's very important to note such points while using graph as a tool. Now let's have a look at one more type of graph and finer aspects associated. Generally, pie chart is used to show a comparative pie in total data values at a glance. Here, pie chart is chosen to show comparative performance of failures on various production batches. However, since the data is for many production batches, assessing, inferring comparative performance at a glance is appearing difficult. Instead, if we combine the data into quarters, will help in drawing inferences as shown in second pie chart, as now it has become less complicated. So in this way, While choosing type of graph, data, we have to ensure that it will help rapid and correct interpretation of data. Histogram is also a type of graph used for specific purpose with data set arranged in typical manner. This is used more in statistics to see the spread of values around intended specified value or arithmetic mean and its nature. Let's have a look at example and see how it can be interpreted in variety of ways. The example talks about certain number of cars of same model, their fuel efficiency measured under identical standard conditions. Number of cars with their fuel efficiency are grouped in certain range of fuel efficiencies like 17, 17.2, 17.4 kilometers per liter. In first graph, we see highest number of cars will have fuel efficiency in the range of 18 to 19 kilometers per liter, which is closer to average or arithmetic mean of 18.6. It drops rapidly as we move away from this average on both sides, which means very less number of cars will have extraordinarily high or low fuel efficiency. This means tight, excellent control on manufacturing process of these batches of cars. The next variation shows us distribution seen normally in nature, wherein the values of fuel efficiency drop slightly gradually on both low and high fuel efficiency sides as per normal distribution curve. The trend here is not as abrupt as the one seen in first graph. More number of cars have low or high fuel efficiency than mean when compared with first graph. Let's have a look at few other possible variations. First variation here shows that highest number of cars have comparatively higher fuel efficiency as most of them including mean or highest point lie on right side of a graph. This is rarely seen in real world due to number of adverse factors. Opposite variation which can be seen naturally in nature wherein higher number of cars may have lower fuel efficiency than mean. So friends, with this we conclude second part of this video, which is the final part. I'm sure you must have understood the finer aspects of these tools which are mentioned in beginning. Please use them and improve the effectiveness of your quality management. Before we close, thanks for listening to me till end, and I'm sure you are now clear about finer aspects of basic quality tools covered in this concluding part, that is graph, histogram and cause of effect and effect diagram. If you like this video, then please subscribe to this channel and recommend others to subscribe, watch and like. Also, let me know if the knowledge information shared is helping you and if you need any specific area to be added in future videos through comments. So friends, with this, let's meet in next video session where we'll go one more step ahead in understanding quality better. Till then, goodbye.